Hello there, my name is Corby. I'm here to talk today about AI agents. This is your standard disclaimer. I'm able to talk to this subject today because of the help from the Spring Framework team who've been helping me write and deliver code for 20 years. The Cloud Foundry team has been helping me deploy applications for 10 years, and Kirti, who helped me put together this talk material but couldn't make it out today. So, I know I said I was going to deliver a talk during this time, but I'm kind of in the middle of something. Y'all don't mind waiting for a minute, do you? I've been working on this application, and it's this Tanzu Platform chat. I still got an outstanding GitHub issue to take care of it. I'll be real quick here. Okay, so it says I need to create a UI for motivating users. In the top level mat toolbar, create a button for increasing motivation, and when a user clicks the button, it will display for 3 seconds when 5 predefined motivational messages selected at random. I can knock this out real quick here. I'm going to jump into my IDE and use my integrated AI tools here. So I'll go ahead and just give it a prompt. And I'll say, let's use this one here. All right, so I'm going to say review issue number 24 in GitHub. That's the issue we were just looking at here. Check out a branch and implement the issue in the branch, perform a CF push, and then create a pull request with your changes. All right, that's gone. And that actually dovetails nicely into the talk because I'm using an AI agent in order to be able to construct this here. So if you know, AI agents are goal-driven software entities that use AI techniques to complete tasks and achieve goals autonomously. That term gets used pretty broadly here, so let's be real specific about what it is that we mean here. So AI agents need to be able to receive instructions. You just saw I gave a natural language prompt to the AI to tell it what I wanted to do. It has to be able to create plans. You can see it's organizing the behavior and figuring out how it wants to go ahead and execute what I asked it to do. And then it uses tools. What does that mean? We're talking about interfacing with third-party software systems. So right now, it's talking to external software that knows how to do things like interact with the file system on my local machine and be able to read and write code files. It is interacting with GitHub in order to be able to manage the issues and be able to issue pull requests. And it's interacting with Cloud Foundry. So it's going to be able to push the application to a deployment environment where I can get it going. If you're not familiar with Tanzu Platform Cloud Foundry, it's a system that runs on top of vCenter, and it provides a developer experience platform where developers worry about writing code, and it figures out all the mechanics of deploying it and being able to spin up data services and all that. The agents have to be able to manage memory, so it needs to remember what happened in the previous steps and what it did before so that it can learn from that and figure out what best to do next. It needs to take actions and accomplish complex objectives. This is important that we're going to talk about here, is that the agent is going to put together a plan, but it needs to be able to adjust to changing circumstances. It needs to be able to evaluate the output of intermediary steps, and it needs to be able to replan. It needs to figure out, okay, based on changing circumstances on the ground, I'm going to modify my plan. I'm going to take a different sequence of steps, and I'm going to continue to course correct in order to get to the final goal that the user implemented here. So my AI agent is doing all that and saving me a lot of time in terms of doing the coding here. Now, when you look at all this here, I mean, how many people here, you know, see an agent like this or maybe some other Gen AI technology and think, hey, I have an idea for something in terms of what could improve my business. I have an idea of something that would add value to my company. Not a whole lot? I guess my creative juice is going. I think this stuff's pretty cool. And a lot of times I talk with customers and they have the same thing. They think, yeah, I have an idea in terms of things we could build and put together and get this stuff going. And I don't think y'all need help with ideas. Y'all are pretty smart. Where Tanzu comes on in is we try and help you get from ideas to code and code to production. So we want to be able to eliminate a lot of the obstacles in terms of taking your idea and being able to turn it into a winning agent process that you can get out running into your company. Now, the problem here is that these agentic applications have a lot of dependencies. It's not just a database. It's not even just an LLM that needs to connect to. There's a lot of stuff that needs to get put together from infrastructure, and that can tend to slow down developers. We'll go into detail on a lot of these dependencies going forward, but the important thing to understand is that, I talk sometimes to devs and they come up with an idea and say, well, why isn't it running? And it's because there's all this mess they have to go through. They have to file tickets, they get approvals from corporate infrastructure. Some of these dependencies are sensitive, like LLMs, and it can be very complex in terms of getting things coordinated, configured, secured, authenticated, and deployed out through your dev, non-prod, and prod environments. We'll go and check in real quick with with our agent and figure out if it got things going here. So it says it's creating a pull request with the changes. So it actually, there we are. And so it actually has deployed it out to Cloud Foundry here. Looks like it needs a little more time. All right. So the Tanzu approach to AI is to be able to take all these dependencies, all these infrastructure pieces that the agents are going to need to correctly operate, and make it easy for the developer to get self-service access to. We've been doing this a long time with kind of traditional database services, but now with the Gen AI tile, we are bringing a lot of these AI-specific dependencies as well, and we'll show what that looks like in terms of the developer experience. Okay, so now we are complete. Our agent has gone through all those steps that we went through, and it created the function, it put it on a feature branch, it pushed that branch out to GitHub. Let's take a look at the pull request it generated here. So very nicely, it ran out a summary and documentation of what it did. We can see the code changes. My goodness, did a lot of files on that one there, okay. And put that out, and it pushed it out to Cloud Foundry. So let's check in on Cloud Foundry and see what our system looks like. Oops, not this one, it's just my other window here. Here we are, let me do a refresh on this. And we got a little button here. So I'll take a look at my motivation button. I'm gonna click it, and all right. Hey, I'm feeling better already. It's gotten me, yeah, all right, cool. Yeah, I'm ready to rock here, all right. Okay, so we got our motivational button, we got this out, and we were able to heavily leverage the AI agent to take a lot of the grunt work out of being able to implement that there. So let's go back to here we are. Okay, so we've got we want to put together a lot of these pieces. What are we going to need in order to build an agent like this ourselves, get this thing up and running and be able to accomplish specific tasks in our enterprise? I'm going to go ahead and continue. I'll go to the production version of my Tanzu Platform chat here because it's good for illustrating how a lot of these Gen AI services are used and consumed the Tanzu Platform. So what I've done, this Tanzu Platform chat is just a simple Spring Boot app. It's just got a web interface, and I can go ahead and use it to do not a lot right now because it's not connected to a model, or it should be here. Let's double check that real quick. We have our application. And we can go ahead and refresh our piece here. And we have our Tanzu Platform chat. And it is set up here. Why does it think that it's connected to a model? It says no services bound. Let's go ahead and just restart this guy and see what he's doing here. All right. I think I may not have restarted after I connected here. So while that's going here, what we're going to do is we're going to go to the Cloud Foundry marketplace here on our Tanzu platform, and we're going to take advantage of the GenAI tile here, which is going to treat LLMs like just another data service on the platform. So as a developer, instead of beginning the process of saying, hey, what models can I use? Can I get permission? What token rate limits am I going to be subject to in order to be able to use this? I have a pre-approved plan, a list of models. Some run on CPUs, some run on GPUs. Tanzu Platform is a great way to provide multi-tenancy for GPU because you can invest in the GPUs on the platform and then allow them to service a whole bunch of different application development teams through sharing here. So the platform team selected the models, they enforced the rate limiting and the permissions in terms of who could use them for what, and then as long as I work within those guardrails, I can go ahead and just grab them as a developer and use them. Let's take a look at how we're doing here. Okay, we're back up. Sorry about that. I hadn't prepped here. So let's go ahead and try one more time. I'm going to say hello, and it's going to say, hey, no chat models available because I don't have anything connected to it. So I'm going to run back over to Tanzu Platform for Cloud Foundry, and I'm going to bind a service to my application. So this is my chat application, and I'm going to select the chat LLM that has been provided by my team, and I'm going to restart the application. When I restart the application, what's happening here is that it's going to inject the credentials for the LLM into my application so that I can securely access them. And as a developer, I don't have to attempt to obtain or provision those credentials independently. So we're back up, and I can check my application, and now you can see I am connected to a model here. So I can go ahead and talk to it, and I can go ahead and introduce myself to it. And basically I have everything I need now to build an AI agent, as long as that AI agent just needs to write funny poems or something. But if I want it to do some serious work, then I'm going to need to build in some additional capabilities. So one of the first things that you're going to want is that, hey, we'd love our agents to be able to talk to our own internal data systems, our own internal documents and data. And there is a technique that was popularized last year for that called retrieval augmented generation, or RAG, which allows these LLM-enabled applications to be able to interact with them. So the way that RAG works is that I can take a document or a database in my environment, and I can run it through a tokenizer, which is basically taking natural language elements and breaking them up into chunks. And then I run those tokens through an embedding model. And the embedding model is going to create a semantic index of the data. And that semantic index, they're called embeddings, but they're just going to be vectors that build out the semantic index. They're going to be stored in a vector database, which is simply a database that's optimized for storage and retrieval of those embeddings, and we'll have the index that way. Now, when I want to actually run a query, I can write a natural language query. I want to talk to that data, right? So the way that RAG works is I'm now going to tokenize and create a semantic index of the query. And then I can put that into the vector database as well and run what's called a similarity search. So the vector database can match up the semantics of my query and the semantics of the existing data and figure out what's relevant. So, for example, if I ask a question, a user question about pets, then it's going to do that similarity search, and it's going to find elements of my documents or data that discuss cats or dogs or horses, because those are considered to be semantically similar to my question and may be relevant to be able to answer that. So The vector database will then return the chunks of the documents that are relevant, and it will supply those to the chat model along with the user query and be able to answer the question. So this is an important technique because it allows us to greatly optimize what it is that we're sending to the chat model. In theory, we could take the entire document set or the entire database, dump that into a query, send that to a chat model, but that would not be feasible from a cost or computational standpoint. That would just be too much resources, too many tokens. So RAG was really important because it allowed us to be able to just pre-select the relevant pieces of data, send a very optimized query out to the chat box, and be able to run those queries there. Now, the only drawback here is that there's a lot of infrastructure needed to support this, right? Now we're going to need to get embedding models up, we're going to need to get a vector database up, we're going to continue to need our chat model, and that's the sort of thing that can slow down the developers on the path to production. So, we can, this is where, once again, Tanzu Platform is incredibly helpful as a developer accelerator. I can go into my Tanzu Platform chat and I see right now I'm not connected to a vector store, I'm not connected to an embedding model. So I'm going to go ahead and go to my Explore chat here, and I'm going to bind these services provisioned and provided by Tanzu Platform to my application. So I'm going to grab the embedding model, and then Tanzu Platform for a long time has supported Postgres as a relational database that can be managed and provided on the platform, and Postgres has an extension called PG Vector, which allows it to work as a vector database. So this is very helpful because now I just got a out-of-the-box service for that. I'm going to go ahead and restart and grab the credentials for my application here. So let's jump on back here, and in a minute here you're going to see it pop in here. It's going to plug in the vector store and the embedding model, and we'll have everything that we need to be able to execute that RAG pattern that we just discussed. We got this here. Okay. So I'm going to go ahead and upload a file. I'm going to grab a Spring Health Assessment Report. This is a just the outputs of a security scan that I did on my Spring application. And so I updated it, uploaded it, and it's gone through that workflow we've seen here. So it's created tokens and embeddings of the document. It's stored those in the vector database. And now I can go ahead and ask a question. So I can say, hey, what is my security exposure? And instead of just relying on the LLM model that was built and compiled months ago, it can leverage the document that I just uploaded and indexed into the database and be able to use that information to answer the query. So this is very helpful because as a developer, it only took a few minutes to be able to get self-service access, but I'm able to start going through these processes, and I'm getting caught up now, and my system is extremely powerful, can answer almost any question except for maybe like what time it is. And how could the system answer that, right? It's using a chat model that was built and compiled months ago. It's using RAG, which relies on documents that were previously indexed at some point. It doesn't know what the current time is. In order to be able to do that, it's going to need to interact with a live running software system. And as you probably saw on that agent I was running earlier, we're very much going to want to leverage interacting with live software systems to be able to do things like commit code and hit file systems and all that stuff in there. So how are we going to start talking to software? We're going to leverage, which you've probably heard, MCP, Model Context Protocol, which is a standard that has become enormously popular recently because of its simplicity and its effectiveness here. So the way that MCP works is that we are going to rely on our existing, we need an MCP client, and for that we're going to use this Tanzu Platform chat that we're using right now, but once we build our agent becomes the MCP client. And then we're going to need a MCP server, which is going to provide, which is going to be a running piece of software that exposes functions and endpoints. So we're going to want an MCP server that can get the current time and that can compute that information delivered to us. And then, of course, we need to leverage a chat model. And the chat model needs to have what's called tool support, which basically means that the chat model needs to be able to reason about, hey, of the functions and tools that are being exposed by MCP servers, which ones would probably be relevant to answer the questions and which ones should we invoke. But the architecture is very elegant because you'll see that the MCP server is completely decoupled from the chat model. MCP server doesn't actually have to know anything about AI or LLMs or anything like this. You can take an existing software and just put a thin API layer shim upon it, and that turns it into an MCP server. So what do those API layers look like? The MCP client basically goes to the MCP server and says, hey, this tools list call, tell me what tools you have. Tell me what functions I can call, what the parameters are of those functions, maybe a natural language description of those functions over there. And then when I get a user query, I'm going to supply those functions along with the user query to the chat model. Now the chat model can optionally say, hey, I think some of those functions that you're exposing might be useful to help answer the user query. So you do this tools call, and it tells the MCP client, it's completely decoupled from the MCP server, so it doesn't know anything about where the MCP server is, but it tells the MCP client, hey, go tell your buddy, the MCP server, to call these functions here, and tell me what the results are, because I think those are going to help me to answer the question. So the MCP server, MCP client invokes the function, the MCP server returns the response, the MCP client gets the results back to the chat model, and then the chat model can figure out, okay, do I have enough information now, or do I need to ask some more questions in order to get where I'm going here? So, like I say, MCP servers are pre-existing applications. They can be written in any programming language, Java, Python, .NET, TypeScript, whatever you want in there. The spec isn't even a year old, but it's just become very popular. We have SDKs available for all the popular languages. And if you go to the Java SDK, you'll see that it is written by the Spring team. So our own Spring engineering team has delivered the Java SDK there, and it works very nicely with Spring AI, which is a developer framework that I use it to build the Tanzu Platform chat, and just makes it very easy to configure and put together these applications. So, but anyway, you can use your language of choice, and then you just need to be able to put the API layer there and go. So because these are simple applications, the MCP servers themselves can be pushed to Cloud Foundry, and within the platform then you can connect the MCP client to the MCP server through Cloud Foundry, and that's what we'll go ahead and do here. Let's go ahead and grab we're going to bind this as a service. So I'm going to take a time MCP server that can answer that question about the current time. And let's just go advanced. Let's do a big one here. I'm going to grab the GitHub MCP server that has a whole bunch of tools here. We'll go to just jump into the deep end on this one here. So, and then I'll restart my application. And the next version of the Tanzu Platform they announced this week is going to have even nicer UI capabilities for being able to publish in these MCP servers, share them with other development teams, be able to easily connect to them, and that sort of thing. So I'll go ahead and jump back into my application here. If I go to my MCP server list, I can see now I have that toy time MCP server that has a single tool, get the current time. Yay. Let's take a look at the GitHub one here. This is pretty good. Like this is maintained, by the way, by GitHub themselves. There's a very rich ecosystem of third-party MCP servers. So if there's a common source code, a CI/CD tool, a testing tool, some tool that's part of your DevOps tool chain, it is very likely the vendor has published and supported an MCP server, which means you can start talking to it and controlling it in your agents here. So we can see there are a lot of different functions that are available in the GitHub MCP server. So I can start asking natural language questions like, hey, what is the most recent commit to the C page, pivotal, CFMCP client repo. And then using the workflow we saw before, it is going to go ahead and invoke the function on the tool and use credentials to log into GitHub and be able to answer the question here. So now you're beginning to get visibility into how this can be helpful with the agents, right? Because now we're going to start adding more and more tools to the agents, and they're going to be able to add them to their bag of tricks in order to do this. So let me go ahead and, yeah, we got time. Take a look at, I just want to show you how simple it is to be able to take your existing applications in the enterprise and turn them into MCP servers. This is a silly enterprise, it's just a silly demo app or whatever that I did for a customer that wanted to see a supply chain use case. So we went ahead and just did a mock factory dashboard, but it's built, I vibe coded it, it's built like a real application. It has an API layer and a service layer and obviously web UI. And all this, and you can do things like check out different stages of assembly, take a look at the health of the components in there. You can see whether or not you're on track to be able to meet your daily production metrics and all this. And I did it as kind of an exercise, say, okay, how much work would it take to turn this into a MCP server? So obviously I need to use the MCP SDK for the language that I'm working in, and in this case it's going to be this factory MCP server here. And so all I did was I just went to I have these two service classes here, factory service and supply chain service. You don't have to understand all the code, but just the point is that these are the same functions that the web UI calls to populate the UI. And for each of my functions here, I added this tool annotation, which basically says, hey, make this available as a tool in the MCP server. I put a natural language description of the function, because that's the chat LLM is going to use that natural language description to figure out, hey, is this something I should call in order to be able to satisfy the query? And also a natural language description of the parameters, so it knows what parameters to send into the different function calls. And so I do this for all the supply chain services and the factory server methods. And I actually got bored of trying to write these descriptions, so I just told an AI to write those for me. He said, look at the code and provide good descriptions of it. And AI is very good for providing prompts that are useful to other AI systems like our agents. And then I just went into the main class here, and I just added these three lines of code. These lines of code just said, go into the factory service method, or factory service class and supply chain service class, find all those methods that have the @tool annotation on them, and add that to the MCP server tools. That's it. That's everything that I did to get that running and turning that into a MCP server. And then I'll go ahead and let's go ahead and take out the GitHub and the time, and I will go ahead and bind the factory MCP server just so we can see that, and I'll go ahead and restart. Okay, and while that's going, I'm going to ask it. It may be in the middle of restarting now, so we'll go through. But I'm going to go ahead and you may remember at the beginning of the session we did chat, I introduced myself to it. I told it my name. And since then, we restarted the system. And what's happened is that the memory is going to be ephemeral. That stuff is going to disappear. Okay, factory server's up. Let's go. I'll show off the factory server real quick here. So now these are the methods that we saw in the code. They're now exposed at tools, and I can ask it, hey, what is the current status of the supply chain? And I'm now talking to my software, right? So it's going to be able to take this natural language question. It's going to figure out what functions to invoke on the software, and I now have the ability to deliver new AI applications that are based on this existing software system with very little additional effort. But let me go and ask it real quick, hey, what is my name? And it's going to say, I don't know, I forgot. I mean, I told it a few minutes ago, you all watched me, but the application lost it and go. And remember, one of the things that AI agents are going to need to function is going to be long-term memory context. It's going to need to be able to remember what it did before and be able to use that information to inform future decisions here. So how can we index all that memory and make it available to the AI for querying? Well, actually, RAG, once again, is the answer. We can use the exact same RAG patterns that we use to index our own documents and data, and we can use that for the memory. So all the requests, all the responses that come on in, we just go and store those in memory, and then we index them with RAG, and then they're going to be available to the system. So after I did that initial introduce myself and restart, we connected a vector store and an embedding model, which means that actually from this point on, we do have long-term memory. So if I introduce myself at this point, it is going to remember. So I'll say, hey, my name is Corby, please remember me. And come on in. All right, cool. So it's going to remember, and now we'll go ahead and put it to the test. I'll go ahead and restart the application real quick. In fact, let me go ahead and while we're at it, I'll just unbind the factory MCP server and go to town here. And we'll do this. So if we get this working, then we're going to have a pretty good tool set here, because we're going to have chat services. We're going to have RAG infrastructure for being able to query documents and data. We're going to have MCP servers that allows us to talk to external software systems. And we're going to have long-term memory. So let's see if we got the memory here. Hey, do you remember my name? And it does. Okay, good. All right, we're in good business now. So now it's storing all the chat information in an index theme where it can easily access and be able to get this information and data here. It's being stored in the same way that we did with RAG. So PG Vector Store is our Postgres database that's operating as a vector store. Every chat request and chat response that comes on in is getting indexed and stored in the vector store in there for retrieval. Yes. Fantastic question. And so we're about to kind of dive into that here. But the short answer is the agent is going to play the role of the MCP client in that drawing. So it is going to interact with the MCP servers, but it needs everything we've done now has been a single request and a single response, right? And what we're going to need is a long-running loop where the agent can continue to iterate, and it can make the request to the MCP servers, reason about the results, and then replan and then make more requests. Is that what you're asking? Okay, perfect.
So the fact that when you're typing, it's remembering certain things like your name and stuff, is that a function of the embedding model?
Yes, so it's a function. So what's happening? So I'm using a library that implements the memory service, and it implements that memory service by doing the same RAG operations that we did when I uploaded that PDF file here. But instead of storing the PDF, it's storing the requests and responses in here. But it's using the exact same infrastructure, the embedding model and the vector database that we used for indexing that document.
So everything that you type in, it goes into the vector database.
That's exactly right. That's exactly right. And you'll see there's a conversation ID in there. So there's meta indexes associated with the vector database. So this ensures that the conversation history is specific to me, and if another user logs in, they're getting their own conversation history, which is going to be indexed and retrieved only by them. Where is the language model? Oh, good question. Good. That's true. That's true. And it's pretty transparent to the developer. So the language model could be in a number of places. This could be a VPAF served model, and the Tanzu Gen AI tile can broker access from the Tanzu Platform application to the VPAF infrastructure. Tanzu Platform also has the ability to provision and manage their own models, which is actually what I'm doing in this particular use case. So if we go back to the marketplace, these are all models that are actually running on Bosch VMs in the Tanzu platform. So the Tanzu platform itself is managing and running them. You can also connect to cloud models. So you can connect to OpenAI, Gemini, Bedrock, whatever it is that you need to do. And the platform operator has to provision the credentials for accessing that and make that available as a marketplace plan. So in my case, my platform operator did not make that available to me as an option. It means that my cursor was over it, I think.
Okay. Well, I'm just curious how this is working without language.
They are language models. So
But there's, for the agent to work, RAG to work, it has to have the language model
yes,
that provides a context
yes,
that embeddings model doesn't. Embeddings model is just embedding. So
that's exactly right.
combination of the two that makes the whole thing work, and I'm not seeing where that is. Because in your private AI foundation stuff, it's all clear. It's your language model, it's your embeddings model, and all the points are visible. But here it's kind of all mysterious. I don't know where it is.
I think Robbie that we would like to see, if I may,
Please, please.
what we would like to see where you tied the agent with the language model. Like in
Oh, yes. So we haven't, we're about to do the agent. So jump in and let me know if I'm answering your question here. But the short answer is the agent is something we're going to, once again, push to Tanzu Platform as an application. And then we're going to bind that agent to the language model that it's going to be using for the services. We're also going to connect it to MCP servers so that it can start doing some of the fun, cool stuff out there. But grab me at the end and tell me if I still haven't answered that question clearly. Yes. Not at all, not at all. Okay, so we have all the pieces now that we need to build the agent. How about building the agent itself? So I am, y'all know who created the Spring Framework? Gabri. Rod Johnson. And Rod Johnson, 20 years later, has created Embable. And Embable is, everything that I've done so far has been built kind of on Spring AI, which is a developer abstraction layer for doing Gen AI and LLMs and stuff like that. Embable is an even higher abstraction level, and it allows us, it uses this goal-oriented planning to be able to implement these agent functions. And so it's a great developer experience. You basically, as a developer, say, hey, here are different tasks that can be performed by the agent. And then when you give the agent something to do, it figures out how to plan and sequence those tasks. And it has the ability to kind of iterate on the plan as it goes along from what it learns. So I've gone ahead. So I'm going to start off with a simple hello world example that Rod provides. And what I'm going to need to do, though, is provide a mechanism for being able to communicate with the agent here. So let's go back to my Explore chat. I'm going to go ahead and bind my Explore chat to RabbitMQ. RabbitMQ is a messaging fabric. So it provides queues and topics, allows for asynchronous request-response communication. And I'm going to use this to connect my Tanzu Platform chat to the agent. So the agent is going to be its own process, individual process. It's going to be connected to a language model that it can use. It's going to be connected to an MCP server that it can use. And let's take a look here. Oh, I haven't restarted, I guess. My bad. Go ahead and restart the application. And we'll be up with the agent. So what I'm going to do is go ahead and send a request to the agent. The agent is going to figure out what are the different goals. So what you'll see here is before everything I've done, so here we are, we're connected, we're on RabbitMQ. I'm going to start with the literary critic. Write and review a story about Las Vegas. So these are instructions I'm sending to the agent, which has its own chat model, and it's using that chat model to do this output. So the output doesn't seem incredibly impressive, but it illustrates some key concepts here. Everything else we did was single request, single response. What happened here is that we had a long-running, not a very long-running, but it was a long-running process that implemented multiple steps and figured out how when it had achieved the goal. So you had one function which was being able to write the story, and it implemented that, and the planning process said, okay, the next step I'm going to need to do for this particular request is to then create a review of the story. And so it does that, and that's all generated by the LLM model. We've got kind of the basics here. We've got a basic framework where we can continue to run, continue to execute, continue to learn from our system. So we're going to do something a little bit more complicated here. So in addition to the coding agents like the one we saw at the beginning, another popular use case right now are the SRE agents, being able to manage and run your own infrastructure here. So I've connected this agent to a Cloud Foundry MCP server, so it can actually perform operations on my Cloud Foundry environment. And so let's take a look here. If we look in my space, I have an application here called Traffic, and I'm going to go ahead and give it a prompt, and I'll say manage the traffic application to ensure that the response time on the /API endpoint is under 2 seconds. And now we can start beginning to see a little more sophisticated behavior. So for example, I did not give it the URL for this traffic application, but it has a Cloud Foundry MCP server. So it went ahead and talked to Cloud Foundry and said, hey, what is the URL for that application? And use that to be able to invoke the service. And then it said, okay, I'm going to go ahead, I didn't get a good response time, so I'm going to go ahead and scale up the number of instances in the application. It's still getting bad response time because I am throttling the environment for demo purposes. So let me go ahead and bring it down to a second so that we'll get a good response time. But it is, there we are. And so now it got a response time of 1056 milliseconds, and it says that, hey, the performance optimization is complete, and this is what I did to get there. So this is a good example of the agent running. It didn't know ahead of time how many steps it was going to have to perform or how to get there, and it had to be able to read and respond to the results on the measurement test, and then be able to use that to inform what it was going to do next and how it got to the completion of the process. So this is connected to the language models, connected to the MCP servers, and it has the ability to run autonomously and do planning and more complex operations. Does that answer your question in terms of how it's connecting to the language model, or?
I think I saw the answer for that. If you go to the binding page,
Yes.
there's two bindings, one for the LLM, one for the embedding model. So I think that's the part.
Yes, so this is the agent I just ran. It's the CF Performance agent. It's separate from my chat application. And if we take a look at it, we'll see that it is connected to the service that way in order to get to the chat LLM. But the Tanzu Platform is basically a broker or proxy to these LLMs. So they can live on Tanzu Platform, they can live on VPAVE, they can live in the public cloud, and it just basically allows dynamic binding and consumption of those chat models. All right, so that's pretty much what we have to get agents up and running on the platform. Any questions? All right, well, thank you for your time.